Hey everyone, welcome back to my channel. This is Rahul. Today we are doing one lead code problem, maximum number of fish in a grid. So it's a medium level problem and we will break it down step by step. I will explain the code line by line so that you will understand every detail. So grab a notebook and let's dive in. Here is the problem. We have a grid, a 2D grid. Okay. So each cell is either land means represented by 0. Okay. Land is represented by 0 and or water containing fish represented by a number greater than 0. So a fisher can start from any water cell and move to adjacent water cell in any direction. Means up, down, left or right. So the goal is to calculate the maximum number of fish the fisher can catch if they start optimally. So if the grid has no water cells, then the result should be 0. If you see this example, you can understand. So from all these two are two adjacent water cells. That's why we are getting the output of 7. Okay. So like that we have to do. So here is our approach. So we will use depth first search method. Okay. First of all, we need to iterate through every cell in the grid. Then we have to if there is a cell contains fish, that is grid of the whichever cell greater than 0, we have to start a DFS from the cell to calculate the total fish in the connected region. Then we keep track of the maximum fish caught across all regions. So let's start our coding. First of all, we have our solution class. Then our main method find max fish with one 2D with one input 2D grader. So here we have to return the maximum number of fish that the fisher can catch. First of all, I need to initialize a variable in order to store the maximum fish count we find during our traversal. So I will give it as max fish. Then we need to use one nested for loop. As you know, it's a 2D grid, so we have to iterate through every cell. I less than grid dot length. Increment I. So this one is for row, another is for column. Grid of I dot length j plus plus. So we're done with our next loop. Then we have to check if the current cell contains fish. I already told what is that one. If grid of I j greater than 0. Okay, this is what I meant by if it is contain fish. We will call a helper function. So we will write that one later. So int uh, I will assign one value here. So we will call a helper function here to calculate the total fish in the connected region. So I will mention like fish in region. BFS of grid I J. Then after this we have to update the max fish as we already initialized there. So we have to find the maximum among the max fish and fission region. The thing is we have to take the one with higher value. So I will use the max method, max fish, fission region. So here we update our max fish variable with the larger value between the current max fish and the fish in this region. Then nothing, we have to return the um, max fish. Now we have to start with our DFS function. So this function calculates the total fish in the connector region starting from a specific cell. So I will start that method public int BFS. We have a 2D grid, right? Grid. Then int I int j. Yes. Now we have to check for one base case. So if the current cell is out of bounds or it's a land cell, means I told you the zeros are land cell. Then we have to return zero. Okay. If I less than zero or I greater than equal to grid dot length or j less than 0 or j greater than grid of I dot length. Okay, one more condition we forgot. So, or I already told if it's a land cell, grid of I j is 0, then nothing much, we have to return 0. That's it. Now come out of the loop. Then we have to catch all the fish at the current cell and set to 0 to mark it as visited. So I will initialize one variable int fish grid of I j, and now I store that one into fish, and now I have to change the cell to 0. Grid I j is 0. Okay. Now we need to recursively call BFS for all adjacent cell. As I told, we can go through up, down, right, left, like that we can do, and we need to add the fish code from these cells to our total. So fish plus equal to BFS of grade I plus 1 or J. So this one is for down. Fish BFS grade I minus 1 J. So this one is for upside. Next, fish plus equal BFS grade I J plus 1 fish plus equal BFS grade I J minus 1. Now we have to return the total fish count for this region. So just return fish. That's it. Where I less than 0, I greater than equal to grid float length, j less than 0, j greater than or equal to, okay, I missed here. Yeah, it's working. So here we done, it's clearly. So with this example I mentioned, here the only thing is one, that is the fisher can start at Z00 and 233 and collect a single fish only. So that's the thing. Now submit it. Yeah, it beats 100%. So I hope this video is good for you, and I think you like this explanation. So if you found this useful, don't forget to like, comment, and subscribe for more coding tutorials. See you in next one.